Class E resonant rectifier. Since a DC to DC converter generally consists of DC to AC resonant inverter and AC to DC rectifier, a high frequency diode rectifier suffers from the disadvantages such as a conduction and switching losses, parasitic oscillations, and high harmonic content of the input current. A Class E resonant rectifier overcomes these limitations. It uses the principle of zero voltage switching of the diode. That is, the diode turns off at zero voltage. The diode junction capacitance is included in the resonant capacitance C and therefore does not adversely affect the circuit operation. The circuit operation can be divided into two modes, mode 1 and mode 2. Let us assume this CF is sufficiently large so that the DC output voltage V0 is constant. Let the input voltage Vs equals to Vm sine omega t. Now, the mode 1. During this mode, diode D1 is off. Then, the equivalent circuit will become the value of L and C such that omega L equals to 1 by omega C. At the operating frequency of F, the voltage appear across L and C is VLC, which equals to Vs sine omega t minus V0 is the output voltage. Mode 2, during D1 is on, then the equivalent circuit will become the voltage appear across inductor L is VL, which equals to Vs sine omega t minus V0. When the diode current ID, which is same in the circuit as the current through the inductor, reaches to 0, the diode turns off. At D1 off, ID equals to IL equals to 0 and VD equals to VC equals to 0. That is, IC equals to C into dVC by dt, that equals to 0, which gives dVC by dt equals to 0. Therefore, the diode voltage is 0 at turn off, thereby reducing the switching losses. The inductor current can be expressed that IL equals to Im sine omega t minus phi minus I0, where Im equals to Vm by R and I0 equals to V0 by R. Right here. When D is on, the phase shift phi equals to 90 degrees. And when D is off, phase shift phi equals to 0 degrees. Provided that this condition is satisfied. Therefore, phi will have the value between 0 and 90 degrees. And the value depends on the load resistance RL. The peak-to-peak current will be 2 Vm by R. The input current has a DC component I0 with a phase delay phi. In order to improve the input power factor, an input capacitor is normally connected as shown here. Now, input voltage Vs diode is on, diode current ID and the capacitor current will be present when the diode is off. So which is going to follow the IL or the current through the inductor. These are the waveforms regarding the input voltage Vs, current through the inductor L, IL, and the current through the diode ID, current through the capacitor IC. This is regarding Class E resonant rectifier. If this video is useful, please like, share, and subscribe.